Hello, everyone. Welcome to Brain Blitz Audios. In today's episode of NEET Preparation, we'll be looking at previous year questions of chemistry in medical entrance examinations in India. So today we'll be dealing with the 7th chapter in the grade 12 syllabus for CBSE. This is a chapter for inorganic chemistry, and the name of this chapter is the P block elements. Now we know that there has been a chapter called the P block elements in grade 11 as well, which talked about groups 13 and 14. So in this chapter, we'll be looking at groups 15, 16, 17, and 18. So we'll be looking at questions of the chapter, the P block elements, which is the 7th chapter in the grade 12 syllabus for chemistry in CBSE. Let's jump right into our first question. The ion or group detected by K2HGI4 is NO, Cl-, NH2-, NH4+. Well, what is K2HGI4? This is known as Nestlers reagent. And the test, which is known as Nestlers reagent test, is used to find out whether there is an ammonium cation. Now, how do they do it? Well, here is the reaction. 2K2HGI4, when there is ammonia in the solution, so it reacts with NH3 and KOH. It gives you the product H2N, HGO, HGI plus 7Ki plus 2H2O. So ammonium in water, it exists as NH4 plus ion. So therefore, option D will be the right answer. When you write the reaction for Nestlers reagent test, you would notice that ammonia, which is NH3, will exist as NH4 plus, and the water will become OH-. The water will have basic ions, OH-. So that's how they detect the ammonium ion in a salt. This is mostly, we will use this Nestlers reagent test when we do confirmatory tests for cations for ammonia. Moving on, let's look at this question. Which of these gases cannot be collected over water? So we have O2, PH3, N2, and SO2 as our candidates. Now, for a gas to be not collected over water, so the setup will be we have a barrier which is hitting a test tube, and we have water here, and we have our gas here. Now, this is what is known as collected over water. Now, if this gas reacts with H2O, then it forms another compound. So therefore, it cannot be collected over water. We need to find out which of these reacts with H2O. Option A is oxygen. Well, H2O is known as dihydrogen monoxide. So H2O is already oxygen reacting with dihydrogen. So it's already stable. And if you add oxygen, it won't react. So option A is incorrect. Option B, PH3, is also incorrect. Note that O2 and PH3 may be soluble. That means they can exist in water. However, they cannot react with water. So most of the time, they would, if you put oxygen gas on top of water, it will stay there with some of the oxygen seeping into the water at specific temperatures. But these can be collected. So options A, B are incorrect. What about option C, nitrogen? Well, nitrogen in its state known as dinitrogen, which is the gaseous state, is generally inert. And the reason why it's inert is that the bond, the triple bond that binds the nitrogen atoms, has a high bond enthalpy. So therefore, it's difficult for water to break these 3 bonds. So therefore, nitrogen is inert. So option C is incorrect. So that means O2, pH3, and N2, if you keep it over water, we can collect it. However, option D, SO2, cannot be done as in that situation. So option D is the right option. SO2 cannot be collected over water. Why? Because when you mix SO2 and water, you get H2SO3, which is sulfurous acid. So if you keep SO2 over water, the water in time would be converted to sulfurous acid. So therefore, SO2 gas cannot be collected over water. Option D is the right option. Let's look at this question. We need to find out the correct order of increasing oxidizing power. And so we have halogens present here. Now, when we look at group 17, which are the halogens, then there's one interesting fact. The metallic character of an atom increases as we move down the group. And when something has metallic character, say metals, they often act as reducing agent. So they have reducing power. Non-metals, on the other hand, have oxidizing power. So they act as oxidizing agents. So therefore, in terms of halogens, where the order is F, Cl, Br, and I, the metallic character increases as we move down the group. Therefore, the non-metallic character increases as we move up the group. So therefore, fluorine has the most amount of non-metallic character. So therefore, it should have the highest oxidizing power. Conversely, iodine has the most metallic character, and therefore it must have the least oxidizing power. And it varies as I2 less than Br2 less than Cl2 less than F2, which is option D. So option D is the right option. In option C, the problem is Br comes after F, which is wrong because Cl comes after F and then Br. In option B, it says that F has the least oxidizing power. However, it is the non-metal here. I2 is almost metallic, has more metallic character. So this order is also incorrect. And in option A, it says that Cl is beneath all the other halogens. However, this order is also incorrect. The right answer is option D. I2 has lesser oxidizing power than Br2, which is less than Cl2, which is less than F2. F2 has the highest oxidizing power. I2 has the least oxidizing power among group 17 elements, or the halogens. Next question. H2S, hydrogen sulfide, does not produce a metallic sulfide with CuCl, COCl, CuCl2, CuCl2, CdCl2, and ZnCl2. Now this question is relatively simple. We need to find out which of these chlorides is non-metallic. When we come to option A, you see that Cu, which is copper, is a metal. So option A is incorrect. Option D, Zn, is also a metal, so it is incorrect. Option C, Cd, stands for cadmium, which is also a transition element, a metal. So option C is incorrect. The right answer is option B, COCl. COCl stands for carbonyl chloride. And this is a covalent compound, without any metal. So there is no metal in here. So if H2S reacts with CoCl2, there is no metal in which H2S can form a metallic sulfide. All it can form are covalent or non-metallic sulfides when it reacts with CoCl2. So option B is the right option. H2S does not produce a metallic sulfide with CoCl2. This is the next question. The correct order of acid strength of oxyacids is, and we have 4 orders given here. So here we're looking at the oxyacids of chlorine, and chlorine is a halogen. When it comes to oxyacids of one halogen, the acid strength, it depends on the oxidation state of chlorine. The higher oxidation state that chlorine has, the more acidic it will be. Let's analyze each of the oxyacids of chlorine here. HClO contains 1H plus, O2 minus, so therefore the oxidation state of chlorine has to be +1. For HClO2, the total charge will be -4, and then there'll be a +1 on H. So for Cl, the charge is +3. For HClO3, H has again +1. This has -6. Therefore, for Cl, the oxidation state is +5. And for HClO4, this has -8 totally, and then there's +1. So chlorine has to have +7 oxidation state. So therefore, in terms of acidic strength, HClO4 is stronger than HClO3, which is stronger than HClO2, which is stronger than HClO. So the correct order is found in option C. This is the correct order according to the acidic strength, which is based on the oxidation state of the chlorine atom inside each of the oxyacids. Option C is the right option. Next question. Chlorine acts as a bleaching agent only in the presence of A. Sunlight, B. Moisture, C. Dry air, D. Pure oxygen. Well, let's look at the bleaching action of chlorine. Cl2 plus H2O gives you 2HCl plus O. So this is where chlorine becomes a bleaching agent. And this is water. So therefore, chlorine acts as a bleaching agent only in the presence of moisture. Option B is the correct option. In the presence of sunlight, chlorine replaces hydrogen in organic compounds. Dry air has no moisture, so chlorine cannot act as a bleaching agent. And in the presence of pure oxygen, chlorine forms oxides such as Cl2O7. So these are some of the oxides of chlorine which is formed when chlorine reacts with pure oxygen. So option B, moisture, is the right option. Let's move on to this question. The laughing gas is NO, N2O, N2O4, and N2O5. NO, which is known as nitrogen monoxide or nitric oxide, is used in chemical signals. So option A is incorrect. Option D, N2O5, which is also known as dinitrogen pentoxide, is used as nitric anhydride. So option D is incorrect. N2O4, which is not dinitrogen tetroxide, is the compound amyl, which is also incorrect. The right answer is option B, N2O. This is known as nitrous oxide, and technically it is dinitrogen oxide, dinitrogen monoxide. This is used in anesthesia, which mean along with oxygen. So therefore, this is having the nickname laughing gas. Option B, N2O, nitrous oxide, is the right option for the gas laughing gas. So laughing gas has the chemical formula N2O, and its technical name is dinitrogen monoxide or nitrous oxide. Next question. The correct decreasing order of basic strength is, and over here we have group 15 elements with their hydrides. So we need to find out which of these is the most basic, which of these is the least basic. When it comes to basicity of the hydrides, it depends on the size of atom. So when size of the atom increases, then the lone pairs are widely dispersed. So they're more dispersed. So that makes them less basic. So the bigger the group 15 atom is, the less basic it becomes. So therefore, NH3 is most basic, and SBH3, which is the hydride of antimony, will be the least basic, and it follows the order N, P, AS, and SB because the atomic radius increases as we move down the group. So the basicity decreases as we move down the group. So therefore, option C, NH3 greater than pH3, greater than ASH3, greater than SPH3 is the right option. Next question. The iodide of Milon's base is HiO3, K2HGI4, NH2HGO.HGI, and HgNH2I. So what is iodide of Milon's base? Now this is the product of Nestlers reagent test. So let's write the reaction for it. So it'll be 2K2HGI4 plus NH3 plus 3KOH reacts to form H2N, HGO, HGI. So this is one product, and the other products are potassium iodide and water. So since iodide of Milon's base is a product of Nestle's reagent test, and these are potassium iodide and water, this huge compound is the iodide of Milon's base. So therefore, option C is the right option. Option B, K2HGI4, is the Nestler's reagent. HiO3 is known as iodic acid, and HgNH2I is mercuric amido iodide. Let's come to the final question of this episode. Which of the following is not the characteristic of interhalogen compounds? They are covalent, more reactive than halogens, have low boiling point and highly volatile, quite unstable but not explosive. So we need to find out which of these statements is true and which of these is false. The false statement will give you our correct answer. Let's look at statement number 1. Interhalogen compounds are covalent. Well, yes, they are covalent because interhalogen compounds are made of two separate halogens. So for example, let's say IF3. Now this compound can only be formed when both iodine and fluorine share one of their electrons and form a shared pair of electrons. It's only when that happens that an interhalogen compound can form. So these compounds are always covalent. Option A is true. This statement is true, which makes the option incorrect. Now, option B states that interhalogen compounds are more reactive than the halogens, which is true because interhalogen compounds have low bond energy between them, and this is due to the dissimilar size in the compounds, because one halogen can only form an interhalogen compound with something with another halogen which is either greater or lesser than it. It cannot form an halogen compound with itself. So therefore, they always have dissimilar size, and therefore they're always more reactive than halogens. The statement is true, which makes the option incorrect. What about statement D? Quite unstable, but not explosive. Well, we know that interhalogen compounds have low bond energy, so therefore they have to be unstable because their bond can be easily broken. So therefore, option D is also true, which makes the option incorrect. The right answer is option C, have low boiling point and highly volatile. This statement is false because number 1, fluorides have high boiling point because of the anomalous behavior of fluorine. And number 2, as compounds become more polar, which is when we go down to bromine and iodine and say a statine, the volatility of the interhalogen compound decreases, so they become less volatile. So that means interhalogen compounds usually have high boiling points and they are less volatile than the halogens themselves. So option C is the right option because the statement is incorrect. The right answer is they have high boiling point and low volatility. So that concludes this webisode of NEET preparation. The chapter pre-block elements has a lot of questions both in grade 11 and in grade 12. So it's imperative that you guys can check out our podcast, NEET Chemistry. Our playlist has a lot of discussions regarding chapters of NEET. So therefore, don't forget to subscribe to our channel, Brain Blitz Audios, in order to access some of our useful and interesting content, such as mind maps, memory hacks, brain games, etc. So until the next webisode, take care, stay safe, bye-bye for now.